Okay, so today I'm going to talk about Kubernetes. When people say Kubernetes, the second thing they always think about is Docker, because Kubernetes and Docker are pretty close related. To be 100% correct, it really isn't. It's a little more complicated than that, but Kubernetes is about maintaining Docker containers. Now, Kubernetes of Docker itself, I don't know if you've seen the logo of Docker, which is like a wheel with shipping containers on it. And it's actually a very good metaphor for Docker containers, like a shipping container, because a container, a shipping container or a Docker container is basically the outside what counts. It has to be in a certain format, and then it doesn't matter where we place it. If we place it in a ship, if we place it in a car or a train, it doesn't really matter that much. The same happens, or the same is true for Docker containers. We can run it everywhere where Docker containers are accepted. Now, if we take that metaphor a little bit further, Kubernetes is not so much a Docker, not so much a shipping container, but it's more the port of Rotterdam. So it's not about one shipping container, it's about a huge amount of containers and trying to organize, make sense, manage all those containers. Containers have to get into the port, it has to get to a certain place for storage, it has to go to the certain ship that is docked there at a certain positions, and all that orchestration is basically what Kubernetes does and does very well. Just like you would not have one or two containers inside the port of Rotterdam, that would be, well, if this Tweede Maasvlakte would have only two containers, it would be a pretty much waste of space and budget, I think. The same is true with Kubernetes. You don't really use Kubernetes for managing only one or two containers, maybe not even 100 containers. There are maybe other ways to do that. Kubernetes is about a huge amount of containers. Who is already running on a containerized system? How many containers are you managing right now?
Plus 100.
Plus 100?
It's built to manage 200,000.
Okay, oh wow, okay. So you probably not do that by hand, all the orchestration. Okay, so today it's about how do I manage Docker containers. This is not a presentation about Docker. I assume, hopefully correct, that you already know a little bit about Docker. If you don't, doesn't really matter. You still can follow pretty much what I'm doing, but sometimes you will see, and I will do things that may or may not make sense, but then again, I may not always make sense, so that's a good thing. Okay, so what I'm going to do is no slides. I'm just doing live demonstration. That never fails on a meetup or conference. Fortunately, everything what I need to get up and running is up and running, so that's a good thing. Let's hope and see if it stays that way. Come on, it's Kubernetes, it must work. Okay, so what I'm going to tell you is first what Kubernetes looks like. Kubernetes basically consists of two different items. Yeah?
Could you tell us a little bit about your background?
My background?
Yeah.
I do not have a background.
It's white.
Yeah, no, okay, well, we don't have a lot of time, so that's why I skip all those things. But basically, my background is development and operation. So that's something that's in DevOps right now, so that's like a really cool place for me to be, which I never am, but I do a lot of development stuff. But this is what I really like as well, so this is what I'm going to show you. So Kubernetes basically exists of two different parts. A master part, which is normally one server, but could be multiple servers, and one or more nodes. In this case, I have 4 different nodes running. I have this running on Amazon. You can run it on your own cluster system of your cloud system. So if you use Google, you can run it on Google. If you use Azure, you can use it on Azure. If you have your own bare metal, you can even use it there. So Kubernetes can run on pretty much everything. It can even run on your own laptop. There's a sort of kind of mini version of Kubernetes called Minikube. And that's basically a virtual machine running on your laptop that is both a master and a node. So you can actually do Kubernetes stuff on your own laptop without having to do all the Amazon stuff of having hundreds of nodes or whatever. So that's really cool as well. I'm not going to demonstrate Minikube, but I'm going to demonstrate it on Amazon as well. But for Kubernetes' sake, it's all the same. Doesn't really matter. So in this case, I have 4 different nodes, and I have only one master node. Some will say, yeah, but one master, isn't that a single point of failure? Yeah, sort of, kind of. But it's like if that master node goes down, it's like being the Port of Rotterdam on strike. Shipping containers won't sync automatically just because Rotterdam is on strike. It just means that if a container goes down, we probably cannot add a new container instead. So we cannot do the orchestration management of the system, but your nodes are still running and your containers are still running. Because in the end, it's about getting containers to run, and Kubernetes is about management of those containers. So 4 nodes, 1 master. The whole of Kubernetes is basically run by an API system. So internally there's an API system which we are going to call. So what I did with kubectl get nodes is basically asking the API system about what nodes do you know, what is running. So it calls the API and the API gives me information back. Normally that's running on the master system. Everything I do works pretty much through the API. Everything Kubernetes does works through the API. That means it's also very easy to programmatically connect to Kubernetes to do things automatically if you want to. Inside, well, you know what? Let's just do a demo, because then you have maybe a little bit idea of what I'm doing with Kubernetes. So let's assume we have a pod. And a pod in Kubernetes is basically, it's not the same as a container, but a pod is the atomic unit. You cannot have half a pod of something. There's only 1 pod, 2 pods, etc. And inside a pod, there's normally 1 container or multiple containers. Sometimes it's useful to have multiple containers. If you are doing PHP FPM with Nginx, for instance, you often have that in 2 different containers, a PHP container, PHP FPM container, and an Nginx container. In this case, I haven't done that. I have got a container that has PHP FPM and Nginx at the same container. It's the Rick Harvey container. If you're doing Docker with PHP FPM, you probably know that container pretty much, because it's one of the most popular containers when dealing with PHP FPM, I think. Anyone uses that container? Hopefully not for production, but for development, that's perfectly all right. Okay, so what we're going to do is we're going to try to get that container up and running, and for this we need to set up a pod. Pretty much everything you do is connecting to the API. So what we're going to do is we post information to the Kubernetes API, and we do that with a simple YAML file. Simple, well, yeah. There's all kinds of information. The most important one is, in this case, the kind. What kind of resource are we actually posting? In this case, it's a pod resource. We have some metadata, the name of the pod, and labels. Labels is something that's very important when dealing with Kubernetes. Labels allows you to select all kinds of pods in all kinds of different configuration. So for instance, I have a label named app called PHP FPM. I've got an environment label named production, and we've got a tier named front end. So what I can do now is I can select all pods that has the app PHP FPM and is running in production and is running on the tier backend, for instance. So that will select a certain group of pods. Or I can select everything that's running in production or anything that's running in development, etc. So with, well, you can get carried away with labels, but don't. But you must not be, try and make as much labels as makes sense to group all kinds of things. We will show you later what you actually can do with those labels. So I have 3 different labels right now. Next up is a spec, and that's a specification of what's happening inside that pod. That pod has certain containers. In this case, the name is PHP FPM app, and the image is Rick Harvey Nginx PHP FPM latest. Of course, nobody uses latest on production, hopefully, but again, it's just for testing purposes and demos. We have a container port, basically our port 80, which we want to expose to the outside world. outside world as in outside the container. So we're still in Kubernetes world. And next is resources. This is very important when you work with not only Kubernetes, but for pretty much everything that's containerized. Try and set the CPU and memory resources of your container. Basically what I say here is I have a system, a PHP FPM pod, which has one container, which runs on 64 megabytes of memory, which has a CPU of 100 milli CPUs, which is 1/10 of a CPU, and its maximum limit is 128 megabytes and 250 milli CPU, or the quarter CPU. So the system cannot basically go any further than that. The reason why you want to do that is because Kubernetes is in charge of selecting the correct node where to place that certain pod. So if there's a pod where there is 64 megabytes of memory free, it can place it on that pod. If you don't specify it, it can place it on every pod, but sometimes you have an application that needs 20 megs of 20 gigs of memory, well 2 gigs of memory, well let's not overreact, 2 gigs of memory, and that will eat up all the resources of that node. So basically you're capping your application to do only its work in that certain amount of resources. So basically this is a soft limit and a hard limit which you set. The next demos will actually not have this, but try and set your resource limits as strict as possible or as efficient as possible, because that makes it very easy for the scheduler to actually move it to the correct nodes. So what I can do now is, after I specified all that information, I can actually say to Kubernetes, to the ABI, I say apply that specification file to Kubernetes. And it says pod PHP FPM created. If I take a look at now, kubectl get pods, I see there's a PHP FPM container is creating. It actually needs to download the image from the container, the Rick Harvey container. It's currently downloading that probably, and it's creating the container, and it takes a while, hopefully not very long. There it is. So now it's running. So right now we have a container running on Kubernetes on a node. We never specified which node. That's for Kubernetes to actually find out. Cool, huh? Woo! But now the proof, because this is, nobody can see anything. So it's running on a node inside our cluster, but we want to expose it to the outside world, obviously. We will do it in another way, but for now, what we can do is the following. We can say port forward PHP FPM port 8000 to port 80. So what I just said is port forward the port 80 inside the PHP FPM pod to port 8000 on my local host. And now, here's where things get tricky. Port 8000. I thank you very much. Now is the time to clap. This is that was the impressive bit. No, so actually we are now looking at the PHP FPM that's inside our Kubernetes clusters running on a certain node. I do not know which node. I do also not know where it is. But basically this is what Kubernetes does. Let's do some fun stuff with it. Let's take that node, kubectl delete pod PHP FPM. That pod is deleted. And now let's go back. Not working. So much for high availability in Kubernetes. So what I did is I created a pod, but it didn't restart that pod, even though that pod was killed. So normally what you want is have a system that says, there's a certain pod, it's not running anymore. Let's try and create a new pod instead and have it up and running. We can do that too. And we can do that, oh, hang on. Where are we? In 02. We did it with a different tool. So what we did is we created a pod, but what we're going to do now is create something called a deployment. We're going to say, listen, we want to deploy a specific set of containers in a specific way and let Kubernetes deal with all the things like scalability and high availability, etc. It works pretty much the same way. It's still a YAML file which we build up, and it looks for a certain part it looks the same as a pod definition because we are defining a pod in here as well. But there's some more information. So first of all, we have a kind is deployment. So we're now defining a deployment resource. We have name, we have labels. In this case, we don't label the deployment, but we could label that more as well. And next up in the specification, we says replicas tree. What we're saying to Kubernetes right now, yeah, of course, the connection timeout. With replicas tree, we're actually telling Kubernetes, I want 3 of those pods running at all times. If there's 1 failing, start a new one. If 2 failing, start 2. If there are 4, kill 1 and make sure it's 3. So that will take care of making sure that we always have 3 pods running on whatever nodes that it needs to put them on. We have a selector, which is not really that interesting. We have a strategy, difficult word, which is rolling update. So what we can do now, does anyone know what a rolling update is? Yeah. Yeah, not everybody? So what you can do is if we have 3 replicas and we want to update the pods, for instance, we have a new version of our application, we can take 1 pod offline, get a new pod with a new code online, get a second pod offline, get a new pod with a new code online, get the last pod offline and get new. So it actually is rolling over the different pods of the different containers that is actually running. So you have a time window where both your application is running with the old version and with the new version. If you work with systems like Capistrano, for instance, they do have something like a blue-green deployment where you actually set the whole system up and running aside to the current version and then flip a switch, or symlink in that case, to the new version. So it's a different kind of strategy, which you can also select here as well, but rolling update is one of the most common one. Then we have a template, and basically this defines our deployment. Again, we have a spec here, and that spec says we have a container named php-fpm app with Richard Harvey ports container 80. So inside the deployment, we define the pod as well, the pod resources as well, the thing that it needs to be, deploy. So it works pretty much the same way, and a lot of things are done through this same method, php apply deployment. We apply that with a kubectl get pods. And now you see there is already 1 pod running, 2 are creating, still creating. They're probably running on a different node, so that node has to get the containers. And if you have to wait for something, it takes a long time. There we are, running. So now we have 3 different pods running. And notice that they are not called php-fpm app anymore, but they have a number, which is actually called a replica set number, and it's got an identifier, which is the identifier of the pod itself, because a pod name should be unique as well. So it actually takes care of this one and this one. If you're going to do another deployment or rolling update, then this number will change and this number will change, but php-fpm will stay there. So we can do the same thing. In this case, we don't go to php-fpm, but we actually get, well, let's get this one. And we port forward it. And there we are running on php-fpm app. This is host name. You can applaud again. But it's cool thing. If we do kubectl delete the pod. The pod. And if we take get pods, then you see it's terminating this pod and it's automatically, instantly creating a new pod as well. So it makes sure that there's always 3 running. So in this case, the system is really high available because it's actually making sure that it's there.
Why would you run 3 pods, 3 of the same pod?
Why would you run 2 of 3 web servers on your...
Does it also load balance between those?
Not yet, but we're coming to that.
Oh, okay.
But that's a good question. So what I did now is I did a port forwarding to a certain pod, but that's just one pod. So what he said, now you want to do something like a high available system where you can actually load balance between these 3 pods, because why would you indeed have 3 different pods? This is where another concept of Kubernetes called services come into play. And services, yeah, I'll take this one. It depends a little bit on how you set it up. Because I use AWS, I'm actually creating a service that uses a load balancer from AWS, but I will show you a little bit later on that. So what I do is I define a kind service. It has some metadata. Type is load balancer. So in this case, it will create an external load balancer, so I can get the information from the external IP of IP or DNS address that I get from Kubernetes. If you do Minikube, for instance, this probably won't have any effect, but you get a URL where you can actually connect to get the output of that. So a service is basically making pods available for outside consumption. That can be outside to the outside world, the internet, what we want to do in this case, but also outside to other pods in your Kubernetes cluster. So if you have an API and a front end that wants to connect to each other, or the front end wants to connect to the API, you have an API service where you connect to. So you don't connect directly to pods, but you connect to services where pods are running in the background. So in this case, I have a type of load balancer. The protocol, it's TCP protocol on port 80 that targets port 80 in the background. And here I have a selector. And the selector here is basically which pods with which labels do we need to select in our service. Now, I specified app is PHP FPM app. So all the pods that have the label app is PHP FPM app will be selected and put into. So I don't specify production or which tier. We could do that as well, but in this case, again, to keep things simple, we just say we select it on the app.
One question.
Yeah.
If you have the selector there and you put in 2 labels,
Yeah.
will it be an or an and?
Ooh, that's a good one. I think an and, but that's a good one to check out. I can't say for certain.
Another question.
Yeah.
You said the load balancer, is that in this case specifying an AWS load balancer?
Yeah.
How does that work? Just based on the name type load balancer? Or?
Yeah, because we're running Kubernetes on Amazon, it says the Kubernetes API on Amazon says I need to get a service with type load balancer, and it automatically knows, okay, then I have to start a load balancer from Amazon. On Google, it will do something different. On Azure, it will do something different. In Minikube, it will do something different. So it really depends on what kind of infrastructure you are running your Kubernetes on, what this does.
You never have to create your own load balancer.
I would not say never, but this is one way to do it. This is probably not the best way to do it, but I don't have much time to show you how to do it properly. But this is a way to do it, because you don't want 100 microservices running 100 load balancers on Amazon, because that's gonna get very expensive. But you can if you want to, but you can also give your money to me. kubectl apply, because that doesn't really change. Oh, what I didn't show you is this. We saw the pods, the PHP FPM pods here, but now, right now we have something called a deployment, the PHP FPM app deployment, which we saw, which is actually running 3 pods. That deployment creates a replica set, so that is where this name comes from, also 3 And I see one here as well, which is the same one. That is strange. I don't see the difference. No, it's the same one. So what I can do now, this is nice about a live demo, because now I have to think about what is the correct command. Scale deploy PHP FPM app replicas is 5. Yes. Poof, and I have 5. Yay! No. Oh, you're too nice for me. Okay, so so this is how you can quickly scale if you want to do that. It has auto scaling as well, horizontal auto scaling. I have that's a whole different ball game. But if you want to scale something up very quickly, this is a nice way to do it as well. But we were actually talking about something else. We're talking about the service. What I want to do is apply that service, PHP FPM app service. And you'll notice that I now have a service. There's always a Kubernetes service here, you don't have to worry about that one. But I have the PHP FPM service of the type load balancer with a cluster IP, which is not really important right now, but with an external IP. And if I describe that information, kubectl describe service PHP FPM service, you will see it actually has a load balancer name. And we can actually get that load balancer name. I don't know if it's already up and running. Probably isn't already up and running. We have to wait for that. So we'll do that a little bit later. But you notice that we have different endpoints. We have an endpoint, this one, this one, this one, and 2 more. So that's actually the 5 services that or the 5 pods that were created that are now running in a load balancer in a sort of round robin way on the system. Now let's see how the load balancers are working on Amazon. So this is my Kubernetes system running on Amazon. There's one load balancer, which always takes a while to put up. There's 0 of 4 instances. So there's 1 in service. Oh, there are 4 in service. Yes, you can do it. DNS is a... Let's try. Do I have the correct one?
What is the health check?
Where do you see the health check? Oh, sorry. Yeah, it always takes a few minutes before those instances get up and DNS get propagated and all that kind of stuff. But we can also, it's not the correct way to do it. Oh, it doesn't even resolve yet. That takes a while. Okay, so we'll take that in a few minutes. Does anyone have any questions about those services right now? So what we can do is actually make a simple system that actually connects to all the different pods in the backend. But those pods doesn't have to, you can actually select whatever pod you want. You can also select no pods. You can also create services that can actually connect to external URLs, for instance. So if you have like a legacy database, you can have a service in front of that and actually connect and make a connection to the service, and that service will actually connect to the legacy database, for instance. So you can still use the Kubernetes or the Docker way to do things, but actually connect to a legacy database. Well, it doesn't have to be legacy, of course. Ooh, we already there? Woo! Okay, so we are now on, I don't know if you can see it, WM2 6FK 35DL. And now it's probably locked on a session or something like that. Then you have to wait a while. 6F, yeah, there we go. So it's actually rotating through all the services one. And so we can kill one service, that is not a problem. It will automatically take the endpoint out of the service so it doesn't keep in rotation. And it spins up another one because we said we needed 5 and there were 4. So it will spin it up automatically. Okay? Yeah?
In this case, how would you point a proper domain to this?
Oh, yeah, in this case you can do it with Route 53, which is Amazon's DNS system. So you can actually say, okay, I want phpfpm.kuberdev.nl load is a CNAME to the load balancer, and that would automatically.
But if that one dies, the service.
Yeah, but it's the load balancer from Amazon, so that doesn't really die if you use the CNAME.
Okay.
Well, they can die, but no, it doesn't change as long as you get the service up and leave the service up and running. If you delete the service and put a new service in, then you get a new load balancer as well. So you have to. There was another question.
Yeah, how does the auto-scaling work? Does that actually mean Amazon auto-scaling?
No, Kubernetes auto-scaling. Kubernetes can take a look at some metrics from the nodes, and based on CPU load or memory load, it can actually say, okay, we need to scale up different pods because the pods are consuming more memory, or if we have to scale down, or if we have to scale more nodes. You can do that, but that's another component that I haven't installed in there for the monitoring and everything.
Is there also a way to then scale to more virtual machines?
Yeah, you can add more nodes to the system. So if I want more nodes, you can do that with auto-scaling groups from Amazon as well. You can say, okay, I want to have more nodes on there as well. It will just automatically add it to the Kubernetes cluster, and it will automatically use pods there. It can arrange pods. It can see, oh, this node is too busy, or I want to get rid of certain pods because they are not as important as new pods I want to install. So if you have like small workers, but you need to have like a new web server pod which has a higher priority, for instance, it can actually kick out pods from the nodes and place them on other nodes to make sure that the most important nodes are running. So it's really it's all advanced stuff, but it's really useful if you want to do like really high available and scalable systems. Just really cool. Okay, we saw services, we saw pods. Now let's do something real. In this case, I have an API written in Silex. What I'm going to do is, well, I show you what is actually happening. Does everybody know Silex or not so much? Okay, Silex is like a micro framework, I guess. Yeah, I'm not a big fan of it. But basically what we have here is we have an application that has the routing hello and then your name, and it will actually print version 1.2, hi there, and then your name. That's it. More than that, it doesn't do. But what I did is I actually built, have a build script that will actually build that Docker container. So I placed the code inside a container. I upload that container to, in this case, my Docker Hub account. So you can actually download it as well. Well, I don't care if you do it, but you can. You can download it, but what we can do then is go to the Silex API and say, okay, listen, we want a deployment from something called the API, the Silex API. We want 5 replicas. It needs to match the Silex API. We need to do rolling updates. And the container we actually specify is kuberdev Silex API 1.0.2. And again, we specify container 80 for the outside world. If you go a little bit down, you see that I have a certain definition inside the same container. inside the same configuration, so you can have multiple things inside one resource, pretty much, of not in the same resource, but in the same configuration file. A service, it actually selects the Silex API selector, which means it matches on these things here, which are these pods, these 5 pods actually. And we want a type of load balancer. And we can do the same thing. Again, we can apply Silex API -f kubectl get all. And we see already our application running here, and this is the new application that is actually being downloaded and installed. We can see that information inside the definition as well, in the pod definition, describe pod here. You can see it actually assigned the pod to a certain node. It mounted some information that it always needs, and it's actually now trying to pull the image that we have created before inside the container, of inside the node. It actually created a container and it started a container. So right now we are up and running. And this works the same way. So if we if we take a look at the services, we can actually see another load balancer up and running, ADC, etc. So we have to wait on that one as well. Any requests in the meantime? Yeah, cool. That's always a good thing. There is actually namespacing. Yeah. What I do now is everything in the kubectl default namespace. Kubectl get all namespaces. And see a huge amount of things running. So we have our deployment inside the default namespace, but there are actually things like DNS controller, kubedns, DNS autoscaler inside the kube system namespace. The kube system namespace is reserved for Kubernetes stuff, so you don't use that. But you can have your own. Well, you could have a namespace called production and a namespace called development or testing or staging and everything. You can actually assign certain amount of resources where you cannot go over the limit of the resources per namespace. You can assign role-based access to certain, well, not so much to namespaces, but to users and to services and to pods inside the namespace. So there's all kinds of advanced stuff you can do with that. For now, I just do everything in the default namespace, but that's just to make things easier. But you can actually have different namespaces depending on your needs. You may or may not use them. It's not necessary, but if you get to larger systems, then you probably want the namespace stuff just to make sure that you don't get into conflict with pod names and service names and stuff like that. Let's see if our load balancer is already up and running. ADC, yeah. Yes. Oh, this is actually a good thing, this error. Sorry. Because I need to go to Hello World, and there we have Hello World.
Could you do this on one load balancer?
Yeah, but that's called ingressing. I have it here as well, but unless you want me to talk for like 2-3 hours, we probably won't make that.
So for like every service, for like every application, you want a different load balancer.
You don't want that. You probably want one ingress point and have multiple microservices going to different hosts or different pods, whatever you want. You can do that. I don't have it here. This is for now. I just do it very simply. One service per load balancer or one load balancer per service. But you don't want to do that in production because it costs a lot of money. You can, but I wouldn't suggest it. Okay. What I want to do here is to see if I can make a rolling update. While true, do sleep 0.5, curl this, done. No. Oh, curl. Okay, so it's just querying the load balancer to see what it's actually doing. Let's trash the Wi-Fi here. Okay, I don't know if this works. I tried it last time with you guys. No? Oh, okay. What could possibly go wrong? Okay, so in this case, I'm going to say version 1.1 is up and running. Semver, so I can break stuff right now. No, I can't, actually. No, I can't break stuff. So let's change it. Let's change something very simple. What I do now is I'm going to build a Docker container version 1.1. You don't have to worry about that, but it's actually building a container and pushing it to Docker Hub. It actually is pushed right now, the rest it already has. Done, 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 done. Yeah, so it's done. What I do now is I go back to that Silex API YAML file. And instead of 1.2, I say I want version 1.1. So I change this, and I say kubectl apply f Silex API. And now it would be fun to see what happens there. So we have 5 instances, 5 pods running. It actually gets that container in right now and is doing a rolling update on the services. So once in a while we should see a 1.1 service. This is of course like a huge container which it has to download. It's probably not Alpine. I think it's a container with Apache and PHP inside, so it's probably a huge container. Do I see it?
Can also get a disk drive and see if
Oh, this is why we do rollbacks. Well,
It's time for the rollback.
Help! My code is always so good that I never have to do a rollback.
Not true.
Rolling update. Oh, rolling update. History. Oh, how's the thing called? Silex API?
yeah.
I have to find the name of the...
Just change the version back.
Yeah, but it would be more fun to actually do a rollback. I know it's possible. I just have to find the correct name.
Wasn't it just rollback and then the name?
I have no. There's there's a history here. Rolling update front end. No, I don't think it's rolling update. It's another one. It actually is. I think. Somebody should have been on Stack Overflow and give me the correct answer by now. Status, deployment, Silex API. Now, I will find it out quickly enough. Let's get this back to 1.0.2 and figure out why it doesn't work.
Rollout undo
Yeah, with?
with, well, here's deployment/deployment, but I guess the name or something.
kubectl get all. What's the name of the? It's actually called. Oh, it's called API. Oh, there we are. Sometimes things should be very easy, and they are. Oh, there we are. We have a few. Oh, there we come. There it comes. There it comes. Woo! The problem is, and I have to figure out what's wrong with it. So that's going to be a problem. So there's a public index PHP. Well, there's not much wrong. What could go wrong here? Yeah, but oh yeah, of course, Composer install.
Talking about Kubernetes and orchestrating stuff and forgetting.
Yeah, this is what a Jenkins machine is normally for, right? Composer install. Yeah, okay. So let's build that crap again. Build a 1.1. Yeah, without Composer it will be pretty hard for a container to run. Well, at least Silex. So now it's pushed. Okay, there we go. We can say kubectl apply f Silex API. No!
I think it's
Oh!
you use the first version.
Yeah,
Yeah, you have to put always pull policy.
yeah. Yeah. Image.
Visual image pull policy always.
No, it's a fix. It's a quick fix. 1.1.1. Build 1.1.1. I'm allowed to do that. Hot fixes. Okay, there we are. There we go. Please work, please work, please work. Oh, yeah, 1.1. 1.1, 1.1.
Some are in there.
No. Come on, more.
You now have fatal and warning. First, it's the same one. Should be the same one.
No.
Nope.
Ah, there we are. Yay! It takes a while.
Almost.
I blame caching. Let's see. Get pods. No. Yeah. Woo! So this we do always on Friday afternoon. Stuff like this. Okay. Phew.
Most of the time you're just scared, that's all.
Huh?
Yeah, most of the time you're just scared.
Yeah. Okay. So that was pretty much running. I have a last thing I want to show you, which is pretty much more the same. So what else could go wrong? But this is a little bit more. So I have to explain a little bit more what I'm going to do. I'm actually have a front-end system, I have an API system, and the API system talks to a MySQL server. So that's a pretty common architectural setup for a lot of applications, or at least the basis. I would not recommend putting MySQL inside a container, but that's a whole different ballgame. But for now, it's okay enough. So what I'm going to do here, let's get rid of some kubectl get deployments. Kubectl delete deployment API. And let's get rid of PHP FPM app. Kubectl get all. That should clean up our, it's still terminating, that's okay. That gets rid. So I want to just to show you a little things. I'm actually using Symfony. Who is using Symfony here? Everybody? No? Okay. Well, I actually have two Symfony projects running here. I have a Symfony project running the old style with the parameters.yaml configuration file, and I have one with the new style environment settings. So there are two different ways, and I actually have them both here as well, so to demonstrate you how to do stuff like that, because that's pretty much the first question you want to answer, get answered when you actually do stuff like this. So this is a more practical use of Kubernetes. So first thing, if you have a MySQL server, you have your database on there that's written on disk. What you do not want is, as soon as the pod gets deleted, that your data gets deleted as well. Makes sense, obviously. So what we're going to do is we're going to create something called a shared storage. So it actually gets a storage system outside of the pods, and it will actually mount that into the pods. There's all kinds of different ways to do that. You can do that with iSCSI, NFS, all kinds of different ways. On Amazon, it basically is an elastic block, EBS storage. Yeah. So that is what I'm going to do in MySQL volume. I basically say I want something called a persistent volume claim with a certain name, MySQL PV claim, and it has certain resources. In this case, I'm going to request a storage of 1 gigabyte. It's a small thing, so 1 gig is more than enough for me. I can say kubectl apply f, well, that should hold no. Yeah, that's up and running. So it's going to create now an EBS on Amazon, which I can actually connect. So next thing we can do is we can create a service. In this case, we have a service named MySQL. The port is 3306, that's the MySQL port. The selector is app MySQL. I haven't defined the pod yet, but I'm going to say any pod that is called app MySQL will be added to this service. So I can define a service before I can define pods. That's possible. That's definitely not a problem. So I can kubectl apply MySQL service. So notice that I don't set type load balancer, so it won't create a load balancer. It actually creates a sort of internal IP address where I can connect to. It also creates a DNS entry, so I can connect to MySQL service, and it will actually get to the service, and that service will route it through to the actual MySQL pods that are running. If you have multiple MySQL servers running, you can do like master slaves in there as well if you want to. MySQL deploy should be pretty much the same thing as any other deployment. Kind deployment, we have a selector MySQL strategy recreate, so it doesn't do any rolling updates or anything. The specification, we use MySQL 5.6, and here we hardcode some passwords and MySQL database user and password. Normally you don't do it this way, but again, this is just for demonstration. The container port 3306 we're gonna expose, and here we're gonna mount something called MySQL persistent storage on varlib MySQL, which is where MySQL saves their databases. Now, what's MySQL persistent storage? It's actually a persistent volume claim called MySQL PV claim, which is actually the name of the EBS we created earlier. So this automatically mounts that thing from 1 gigabyte we made earlier. It mounts automatically to varlib MySQL. And since MySQL saves the data there, it will be stored on persistent disks and not inside the container where it gets deleted every time we destroy it. Is that clear? Yeah? Cool. kubectl apply f MySQL deploy. And now we have one MySQL server creating. Maybe we can actually see the volumes. Oh, here we are. So here's one volume that actually is mounted to a certain host, to this node inside Amazon. So it automatically makes sure that it gets mounted to the correct positions. That's pretty much up and running. I can actually do things like port forward now. To give you this name, port forward 3306 to 3306. Oh. And if I do telnet to 3306, because I don't have a telnet client here, I can actually see the entry point of the entry from MySQL. So this is actually running inside the cluster, this MySQL. Okay, hopefully you believe that, because it really does. Next, we go to let's go to the API. So the API is nothing more than a simple Symfony application, which has its configuration and everything in. But what I want to do is I want to store the actual parameters YAML file outside of the container. I don't want to hard code all that information inside a container. I want a container to be usable in production, in testing, in acceptance, in staging, etc. So I need to find a way to actually get the parameters away from the container. So here's what I do. Let's see if this is the correct one. No, it's not in the API, it's in the front end. I do this, it's the same thing. What I do is I have my parameters.yaml file. So this is going to be my production settings. The only thing I need, this is not a database, this is the front end, so the front end doesn't need any database, but it does need a connection to the API service. We haven't defined it yet, but pretty much we're going to define a service called API service, and I can call this host name, and I can go directly to there, and it will actually show the API. So that Kubernetes takes care of all the host name, etc. So this is a file, and what I do is I store that file pretty much as a configuration file inside Kubernetes, and I do this through something called a config map, which is nothing more than create a config map called front-end parameters YAML from the file parameters YAML. So the production settings in this case. Run config map. Run config map. So it's created there, so there's a config map right there. Now, then I have a front-end service, which is exactly the same thing as we saw before. It's a service named front-end service with the app front-end, port 80, and we want to expose. The selector is app front-end, and type node port. That means it's available on pretty much the cluster. You don't, in this case, you might not need it, but this is okay for now. So, my MySQL, kubectl apply front-end service. So we have the service up and running. Now we take a look at the deployment. So this is where things get a little bit different. So it's still in the deployment. We still have replicas, we still have selectors, and we still have a strategy. The template is pretty much the same. We have a container called kuberdev frontend 1.0.4. That's the compiled front-end application I've created before without the parameters.yaml file. Here's my image pool policy, so this one will work hopefully. Here I say volume mount the volume front-end parameters YAML on /config. So pretty much the same thing what it did before with a persistent volume claim, I'm actually doing now with something else. This one. So what is front-end parameters YAML? It's actually a configuration map called front-end parameters YAML. So now it knows it doesn't need to store an elastic block or a disk, but it actually has to mount a directory with that configuration inside. I actually mount that on /config. I will show you why. Because if I mount it on, in this case, vaag www html app config, for instance, I will lose all the configuration files that are already present inside that directory. So what I do is I mount it outside of my application, and then as soon as the container starts, I actually do an execute of a command. In this case, the command is I'm going to link config parameters.yaml on that mounted configuration, on that mounted config map, to file www html app config. So it will actually link that to our application. And then, just for the fun, I do a cache clear on the environment just to make sure that everything gets up and running with the correct configuration settings. And from that point on, it actually works with production settings. So it's just a matter of getting the configuration into another into another place, mounting it, and then symlink it to the correct place, do a cache clear, and that's basically it. I have to do this a little bit more quickly. Apply, front end, deploy. Get pods. So now the container is creating. What I'm actually going to do is kubectl execute bin bash. So now I'm actually inside the pod, inside one of the pods. And if you take a look at /config, you notice there's one file called parameters YAML. It creates it all kinds of difficult ways, but basically that's how it mounts config maps. And that parameters YAML consists of our data we saw before, and var HTML app config. Here is where we created our symlink to config parameters. So this is not present in the container itself. We create it outside the container when it starts. Okay?
Why do you still have parameters YAML distributed?
Because I didn't clean it before actually running building the container.
So you don't need it.
You don't need it. No, true. This is the normal way when you work with parameters YAML, but this works for other files as well. If you have like an Nginx where you have your own configuration file, you probably do it in similar ways. What we do now is the API, and the API actually uses environment settings. And this is a little bit easier. Well, sort of easier, because Kubernetes doesn't make things very easy at this point, because what we need is a secrets file. That secret file looks like this. It's not that secret, it's just base 64 encoded. So when I say app-env and I run this through echo this through base 64 decode, I actually get prod, which means it has the production setting. And if I take this, the database URL, I actually get MySQL Symphony, the user password, at MySQL, because that's the name of the service we created, port 3006, Symphony database with charset, and version 5.7 while we're working on 5.6. But
still didn't change it.
Still didn't change it, no, but that's okay. So when you create a secret, you actually have to base 64 decode that encode that secret before you can actually use it. It's a bit of a hassle, but that's how it works, unfortunately. What I do, API service. Now let's take a look at service. This should be simple. It's the same thing. We have a service named API service. This is where the front end connects to. Port 80, selector app is API, node port. So that's all pretty much the same thing. kubectl apply the secrets file, apply the service, and then we have apply deploy. Again, it's a deployment. It has 3 replicas. It does a rolling update, and it has a container Kubernetes API. But this says environment from the secret reference prod API secret, which is the secret file we saw. So what it does now is take a look inside the secret file and gets every line in there inside the environment settings. So if we run this, kubectl apply API deploy, kubectl get all, the API is getting ready. We say kubectl executes bin bash. Yeah, we're inside. And when I do an export, I can actually see my app debug, app-env, app secret, and database URL set. Notice that it also set information about AP service port, front-end service port, Kubernetes port. It also automatically set that information as well. If you want to connect in a different way, not through the DNS name, but through the environment settings, you can do that as well. So there are multiple ways to connect to a service. You don't need to use the DNS, but you can use that one as well, but it's not used that often in what we are doing. So there's all kinds of extra information that will get added to a pod as soon as it starts based on the services and everything that you are running. So that's all up and running, so that's cool. And what this does is, this is actually the Symfony 3.4 or the 4.0 version of Symfony, where it actually uses the environment settings. So you have stuff like packages, doctrine.yaml, where you have the dbase URL, environment dbase URL. So that's how it gets inside Symfony as well. But I think Laravel can use environment settings as well, right?
Yes.
Yeah, so that pretty much works pretty much the same way. A lot of Laravel people here, yeah? Yeah. Symfony, nope. Laravel, yep. Okay, so that's pretty much up and running, right? We have an API, we have a front end. Let's get out of here, kubectl, get all. We have an API, we have a front end, we have MySQL up and running. Cool, so how can we connect to here? Actually, we can't. What we should do, sorry for that. I need to create another load balancer. kubectl apply, should have done that before. So I create a load balancer for the API, and I'm going to create a load balancer for the front end, sorry. Balancer, kubectl apply a front end front end service, kubectl get services. Oh, that's gonna cost me a fortune. It's starting to new. We can do it with a node port, but then again I have to get extra information in. But this is easier. So let's hope that this will, or this does not take too long. Then we are actually pretty much finished. This is a new one.
How much will this cost you, this presentation?
Thousands of euros. Nah, I think a load balancer is like $15 a month. So it's still not a lot, but if you have 1,000 load balancers running, that's a bit of, yeah. Okay, we still have to wait on the load balancers. Still out of
$15 a month, you would expect it to be up.
Yeah, well, actually, AWS, oh, of course, yeah, sure, update, why not? We're just using Wi-Fi on a presentation, so no problem. We were so close. Are we already up and running? Out of service. In service, yes, yes. Oh! No.
Denied.
Question.
Yeah.
The resource specification, can you also specify network limits, network usage limits?
Wait,
No, I think there are some things that can be like compressed. If like CPU, you can throttle CPU. You can also throttle networking. I don't think it's already there, but I think there are like should be able to do that, but not yet.
Because it is using an overlay network.
Yeah, so it.
Internally,
Yeah, I haven't discussed it, but you can actually use other overlays as well, because there are actually restrictions to the default overlays when dealing with AWS, for instance. But yeah, that's too much for an introduction, Kubernetes, to be honest. Anyhow, we're actually running our API. So I had whole discussions, why do you need CSS on an API? Well, to show you this. We can actually get, oh no, this will fail, but bear with me. Yeah, so I get internal server error, right? And if I go to product, I get that too, that's correct. Really? Oh no, this is running in production, so I can't show them. Trust me, the reason for this is we have a MySQL server, but we never created the schemas for that because you need to have a schema in there. Fortunately, Kubernetes has some cool stuff for that as well. Front-end API, and then we go to Kubernetes, which is actually called a task. And a task, or job actually, it has a name, it has a template, and it has a specification. We're going to say run the task in kuberdev API, so we have the API container to run that task. But run, instead of doing your normal stuff, actually call PHP bin console with doctrine schema create. So what it does, it posts this job to the API server. The API server checks to see if checks the scheduler to see where it can actually put the job. The job will run. Notice that I don't have any resources here, but normally you have resources there as well, which probably is less than when running on the web server side. But if I run this kubectl apply f API tasks, kubectl get jobs, it's probably still running, or oh yeah, there it is. Kubectl log so there you see, I can actually log information about what's happening. So you can see what the output of that bin console command was here as well. So in this case, I created a doctrine schema, which was successful. And now, it says, yay, 200 okay, but there's nothing in there, which is good, actually. So, especially for Tim again, I'm gonna, yeah, sorry. Name is Tim. Price is, well, 99 cents. And let's execute this. And now we should go to products.json. And there we have our JSON with our, from the API. Cool? Yay! Hang on, this, if you think this is right, nice, then take a look at this. So now we go to the front end part. Front end, so this is the front end that actually connected to the API, that connected to the MySQL database to give Tim. Nice. So pretty much in a nutshell, this is what a lot of work, what we do on a daily basis actually is when we create APIs, but now running on Kubernetes. So we can scale the out of it if you want.
For all the people that want to buy Tim.
Yeah, oh, this is going to be massive. Tim is going to be massive.
Yeah.
It's like the next Bitcoin.
How would you manage the backups of databases and storage sizes of the systems?
We don't do backups. No. Backups means that eventually you will that you will fail in some point in time, and we never fail. Not me. No, pretty much it's just a database. So you use the same backup methods as you do in on a normal. So you probably run a task, for instance, where you can actually do a MySQL dump on a slave server, for instance. Something like that, you can do that as well. So you can actually, in the latest version of Kubernetes, you can actually have crons as cron jobs as well. So you can say, okay, every day at 4 o'clock in in the morning I want to do a MySQL dump of the database, for instance. So you can do all kinds of stuff like that as well. So that doesn't change with Kubernetes.
And if Kubernetes dies for any reason, this would still work?
This will work, yeah. If the master node dies, but you cannot scale or get new pods up and running. But this works, because this runs on the nodes, so as long as the nodes are fine, it works.
Can you reconnect the nodes to a new master?
And already running, ooh.
Well, if the master dies at some
Oh
point-
yeah, no, yeah, obviously, yeah, no, but it's in the same Kubernetes cluster then, obviously. So it spins up a new master, or you can scale the masters if you want to as well, and then it will automatically connect. So that's all like magic. It's really cool.
Can you tell me, a lot of what you've shown can also be done in Docker Cloud or Docker Swarm.
Yeah.
What would be the tipping point when you want to move to Kubernetes?
Sorry?
What would be the point where you want to move to Kubernetes?
Oh, I don't know.
Really don't know.
No, I can't tell you. I think that's for everybody different. One of the things is that Kubernetes is getting more and more standard, but like OpenShift, and now Rancher is doing Kubernetes, and there's actually Azure is doing native Kubernetes. Google Cloud already does it. Amazon actually does not do native Kubernetes. So it's like, who's going to be on top in a year or so? And considering how Kubernetes is growing right now and how it works, my money is on Kubernetes, but yeah, there are other things, other systems that pretty much work the same, or not the same way, but does the same thing. Yeah, definitely. Yes?
If Amazon does not do Kubernetes native, how did you create this cluster?
Actually with a tool called kops, K-O-P-S, which is Kubernetes operation, I think. It's literally, I can show you, it's just a one-liner. I can actually, again, this is not the way you set up professional cluster, but you can actually do production grade clusters with that. I just say create a cluster in these zones with the master certain size, with the node count, the name of the cluster, have all kinds of information. You can say I want to have a private network and have a bastion station or jump station in front, and you can there's a lot of parameters that you can actually set up a COPS cluster. But you can do it yourself the hard way. Kelsey Hightower has like a documentation on setting up cluster Kubernetes the hard way. You can try to do that, but I would suggest getting it up and running with COPS first, because that makes it a lot easier.
Is it actually called that? Setting up Kubernetes the hard way?
Yeah, it's actually called the hard way. Yeah, and it is pretty hard. Yeah, because if you see what actually is running inside kubectl get all name. So all this is running in the background, and you need to get it up and running, and they all connect, the master nodes, they all connect with SSL certificates, so you need to have a certificate authority and have everything up and running. So there's a lot of systems that does it automatically for you, like COPS, but if you use Minikube, which I probably have here as well, I can actually say Minikube start, and it will do everything for us, but it's just a single node where the master and a node is in one virtual machine. So now it actually starts up Kubernetes for me to pretty much do the same things what I did before. I can do it there as well, but just on a single node, obviously. But I don't like to do it locally. Why? Why do it locally when you can do it on the internet?
You can spend money.
Yeah, I'll live that extra $1. That's not a problem. Okay, any more questions?
What if you're not using a tool like Kubernetes? How would you manage your containers otherwise?
You have things like Docker Swarm and Mesos and all that kind of orchestration tools, but you need orchestration. After a while, if you have like 3 or 4 containers, you can maybe do it manually, but after a while, this is not something for like a few containers. This is for like what he said, like dealing with hundreds of thousands of containers. Then you can manage stuff like that. Without it, it's impossible. but only 3 or 4, yeah, I can do that manually if I want to. Oh, so now we have Minikube running as well. Oh, it's not ready yet, but it will be soon. So that's Kubernetes, pretty much. Okay? Well, thank you.